Let's talk tech. Exploring tech together.
All right, let's talk about something that drives pretty much every software team crazy at some point, the code review. In this explainer, we're going to dive deep into how you can actually build an AI-enhanced system that turns this whole messy process into something, well, smart and genuinely helpful.
You've seen it, I've seen it, we've all seen it. Those three little words on a pull request, looks good to me. And hey, sometimes it's true, but a lot of the time, it's a sign that something's off. Maybe it's reviewer fatigue, maybe it's an overloaded workload. That simple phrase, it's really just the tip of the iceberg for a much bigger problem.
So let's get real. Why does the code review process feel so broken so often? Well, as teams get bigger and code bases get more complex, the whole thing can become this subjective, slow, and honestly a massive bottleneck. Let's break down the usual suspects. What's wild is how universal these problems are, right? One day you get feedback from one person, the next day a totally different take from someone else. You've got that end-of-day fatigue where you're just clicking approve to clear the queue. Then there are the knowledge silos, where only one or two senior devs can actually review a certain part of the code. And all the while, the mountain of pull requests just keeps growing. Sound familiar? I thought so. This is where AI steps in. But, and this is a big but, we're not talking about replacing human reviewers. Not at all. Think of AI as your new teammate. Specifically, a tireless junior reviewer who never gets tired, never has a bad day, and can check for all the simple, repetitive stuff with perfect consistency every single time. So the key here is knowing who does what. AI is absolutely brilliant at spotting repeating patterns or flagging when someone isn't following the team's coding conventions. But it has no clue about the why behind the code. It can't understand the business purpose, it can't weigh complex architectural trade-offs, and it certainly can't replace nuanced human judgment. And that leads us to the game plan, which is actually super simple. We let the machine do the grunt work. Let the AI catch all the obvious, low-hanging fruit early on. This frees up your human reviewers to use their valuable brainpower on what really matters, the logic, the architecture, and whether the code actually achieves its goal. Okay, so how do we actually build this thing? I know it sounds really complex, but the whole system can be broken down into a pretty straightforward 4-layer blueprint. And the best part? It hooks right into the workflow developers already use, so it doesn't add a bunch of friction. Let's walk through it. So the process flows like this. It all starts with a pre-commit hook, so it runs automatically before a developer even pushes their code. That hook then uses something called code embeddings to figure out what the code is doing. Next, a large language model, an LLM, evaluates those changes against your team's rules. And finally, it gives clear, actionable feedback right back to the developer. All of this happens in seconds. Now for the foundation, you've got Git hooks, which kick everything off automatically. But the real magic is in the codebase embeddings. Think of it like this. The system creates a unique numerical fingerprint for every single function and class in your code. These fingerprints get stored in a special kind of database called a vector database. Why? So the system can instantly find similar code anywhere in your entire project. This is what lets the AI be truly intelligent. We've got the architecture down, but let's talk about what makes a system like this feel genuinely smart and helpful, instead of just being another annoying linter that everyone ignores. It really comes down to the quality of the feedback it gives. So what does intelligent actually look like in your editor? Well, it's the system flagging a function you just wrote and saying, hey, this looks about 95% similar to this other function over here. You should probably just reuse that. Or it could stop you from calling a database function directly from the user interface, protecting your architecture. It can catch you accidentally committing a hard-coded API key. And maybe best of all, it can enforce those unique rules that are specific to your team. You know, the secret to making this work without driving developers nuts is the quality of the feedback. And that all comes down to giving the LLM a really well-structured prompt. A good prompt doesn't just bark, "This is wrong." It clearly explains what changed, which rule was broken, and this is the most important part, what the recommended solution is. That's how you build trust and make the tool feel like a helpful guide, not a nagging critic. But you know what? None of that matters if the tool is slow. For a pre-commit hook to actually get used, it has to be blazing fast. We're talking under 30 seconds max. Because let's be honest, if a tool makes a developer wait, they're just going to find a way to disable it. Performance isn't just a feature here, it's an absolute must-have. Okay, so you've built this awesome system. Now what? How do you roll it out to your team and actually prove that it's making a real difference? Because success isn't just about building the tech, it's about getting people to use it and measuring the real impact. Here's a great low-friction strategy. Start small. Don't force it on everybody from day one. Let curious developers opt in first. You can even run the tools silently in the background on your build server for a while, just collecting data. Then, when you're ready for the big announcement, you can walk up to the team with hard evidence and say, hey, look, for all the PRs where this was running, we saw a 20% drop in bugs and reviews happen way faster. Data talks. And when we talk about data, it's so important to track what actually matters. Steer clear of vanity metrics, like how many comments the AI generated. Who cares? Instead, focus on the impactful stuff. Are your pull request cycle times actually getting shorter? Are fewer bugs making their way into production? Are new developers getting up to speed faster? That's the data that tells you the real story. Which brings us to the most important point of all. The goal of a system like this is not to control developers or just enforce a bunch of rules. It's to reduce their cognitive load. It's about taking the boring mechanical parts of the job off their plate so that they can be freed up to do what humans are amazing at, solving really hard problems and thinking creatively. And that really just leaves us with one final question to think about. If all the tedious, repetitive checks in your team's code reviews were just handled automatically, what would you focus on instead? What bigger, more interesting problems could your team solve? That's where things get really exciting. Thanks for tuning in to this explainer.